Well, what we have now is electrostatic induction. This is a process of electrically charging an insulated conductor using the force due to a charged object to separate the charges in the conductor. And this is what we have. This is a conductor. This is a metal sphere. This is a metal sphere. Metal sphere A, metal sphere B. They are electrically neutral, meaning that the charges inside them, they balance. So we have the same number of positive charges and negative charges. And here we have an insulator, to prevent charges flowing between the sphere and the ground. And the two spheres are in contact. So they are in contact. In contact, it means electrons are able to move from one sphere to another, just like we have electrical conductors in our houses where current flows, because they are conductors, they allow the flow of electrons. So as they are in contact like this, electrons are able to flow from sphere A to sphere B, or from sphere B to sphere A. Remember, only electrons will be able to flow. Now, what we now have is a charged rod, a negatively charged rod. Here is a negatively charged rod. So this negatively charged rod, what does it do? Remember, only electrons can move. So because it's negatively charged, it repels electrons to the far end of sphere B. So the sphere A at this point here, next to this rod, will have more positive charges. So it is positively charged because its electrons have been repelled to sphere B. So this is what we see. Then in this diagram now, diagram C, what we do now is we take sphere B away, we separate the two spheres. So they are no longer in contact. As we can see, they are no longer in contact. And to achieve what we want to achieve here, to separate the charges, we have to take away sphere B while the charged rod is still in place, because if we were to take this rod away, the charges will quickly flow back to sphere A to neutralize sphere A, and the end result will be just like what we had in diagram A. So we remove sphere B while the charged rod is still in its place. So still repelling these negative charges, right? Then after separating the two spheres, we can now take away this, and what we have is this D. What we notice here is the charges are evenly distributed. They are evenly distributed here. And the positive charges are evenly distributed as well, because they cannot be closer together. It doesn't make sense because there is a force of repulsion between them. So with regard to negative charges, they move around until they are evenly distributed. As for positive charges, they don't move. What really happens is the negative charges are just going to rearrange themselves such that they balance the positivity of the sphere throughout the sphere. So they don't really move. It's actually the electron which moves. It's actually the electrons which moves. Now let me do another example. Supposing we had sphere, call this sphere A and this sphere B, and we have our insulator. So instead of bringing a negatively charged rod, I'm going to bring a positively charged rod like this. Positively charged rod. As I bring it closer to sphere A, what is going to happen is it is going to attract electrons from these spheres. So more electrons are going to flow to this end. And as a result, we are going to have something like this. So because I have drawn 4 negative charges, I have to show 4 positive charges this side where the electrons came from. So the charges have to balance. Even in the example above, you will notice that the charges will always balance. As for this one, no, it doesn't have to balance with the charges on the 2 spheres. So if I now take away sphere B, we will have something like this. Right? Remember, we have to take away sphere B while sphere A is still next to the positively charged rod. So because this one has been taken away, it will have positives like these, positive charges like this. And this one, if we now take away this rod, the charges in this sphere will, oh my god, I cannot, it's a different page, so let me do this. Okay, here is our sphere A, having taken away the positively charged rod. So these negative charges will now redistribute themselves evenly. So having taken away the positively charged rod, our negative charges here will redistribute themselves evenly, and we'll have something like this. See? So now this sphere A is negatively charged, sphere B is positively charged. So this is how separation of charges works. physics. So with regard to earthing, really, if we touch with our hand as shown here, the charges which were here will move through our body to the ground, because it's actually what? Electrons. So what if we had something like this? Supposing we had something like this, right? Yes, something like this. These are positive charges. So if you touch with your hand here, if you touch with your hand here, what really happens is these positive charges, they don't fall to the ground. What happens is electrons, they come from the ground, move through your body and come inside this sphere to neutralize these positive charges. I'm just trying to emphasize the fact that it is the electrons that move. If your sphere is positively charged, electrons will come in from the ground as you touch or as you connect a conductor to the sphere and the ground. If it is a negatively charged sphere, electrons are going to literally move from the sphere to the ground. But for positive, remember, electrons are moving from the ground to the sphere. That's one thing that we shouldn't forget at all. Yes, that's it. So the next thing are insulators and conductors. We are going to look at these under current electricity, which will be the following thing that we need to do. And but before we go there, we are going to solve problems on static electricity to make sure we understand everything that we have discussed so far. That's the end of our static electricity. So we are done. Thank you for watching.